maybe tomorrow one of your OEM comes and tells, we have enough technology in-house to build our own chargers. So do you see that as a risk?
See, I think that's a risk always for like any industry where you can have backward integration, right? So one, they'll see we are experts in this, we understand this very well, we are innovating faster. The second thing is that because as a supplier or a partner to them, we'll have economies of scale because we're supplying these not only to them, we're also supplying this to like 10 other EV manufacturers. Vertical integration is very important initially on, right? Because these are, like you rightly said, from a technology point of view, still very new. If you look at it, we're actually a power surplus country officially. The amount of power we generate is enough to meet our needs right now. Let's say even a typical residential distribution transformer, which is serving 20 flats, let's say, or 20 or 30 flats in Bangalore. So typically these transformers will be rated anywhere between 100 kVA to 250 kVA. So during the day, you'll not have any issue. But then now everybody comes back in the evening and everybody puts their ACs, chargers, everything, right? It happens at the same time. So like the peak happens all at once.
Today we have with us Zohra Khan, who's the CEO of IPEC India. So IPEC is they build basically EV chargers for home and public charging stations for various OEMs basically. They also build software that helps manage and monitor charging. So this is about IPEC India. We'll now go on to deeper questions for Zohra herself to answer. We'd love to know about your journey about the IPEC India.
Hey guys, so first of all, thank you so much for having me on this podcast. I will first introduce IPEC. I would say IPEC is a power electronics company. We design and manufacture EV chargers for the Indian market. These include home and portable chargers. We also do public charging infrastructure, which has not just the hardware of charging, but it also has a complete monitoring software as well as a mobile app. We supply to the leading two-wheeler and three-wheeler EV OEMs in India, and now we are diversifying into the four-wheeler and the bus market as well. What makes us different is our roots. I'm a third-generation entrepreneur from the Meher Group, and which has been building power quality systems and power electronic components for more than 45 years in India, which means we understand the unique grid conditions here better than most of the companies and most of our competitors. So I actually spent the first 6 years of my career working at Meher, developing and building products for power quality. Post that is when we decided to start IPEC. This was back in 2017. So that's when the entrepreneurial journey began, and we wanted to focus on e-mobility because that's where we saw a very large opportunity, and it's a very important subject also for India from an energy security perspective, from an environmental perspective. And so there were a lot of things coming together. And that's why we decided to start this company, IPEC, to focus on power electronics for mobility. That being said, this is just the starting point. There's a long way to go. Mobility is just our first focus. And of course, we'll be looking at other areas like energy storage, also power management for different industrial applications. So this is just the beginning.
So regarding the product side, right? So we'll start off from the product end of your company. So you supply chargers to various OEMs. For example, maybe Ather, Bajaj, right? How do these chargers exactly differ from each other? So are there different requirements for each chargers, or how do they differ basically?
So honestly, they have a lot more in common than people think. At the hardware level, what you're doing is you're fundamentally moving energy from an AC power grid. You're converting it into DC, and then you are charging a battery. So that's essentially what you're doing, right? So the main power electronics, which is at the core, which mainly is a rectifier, then you also have multiple conversion stages and also protection circuits which are required to protect these electronics, right? So this is largely the same across all OEMs. So whether it's an Ather or an Ola or let's say a Bajaj or any of these OEMs, the basic hardware remains common because the function is the same. Where it actually differs is on the software protocols. So the language that each, let's say, battery management system on a vehicle speaks is very different. So that's why we need to actually customize the softwares. We need to integrate this very tightly with each OEM's battery management system, which enables the charger to talk to these vehicles. Right. The other thing which is different is the actual connectors, which is the physical interface which connects a charger to the vehicle. So this also has been largely different. If you look at four-wheelers, it has been standardized, but India, mainly if you look at two-wheeler, three-wheelers, everybody has been on a different connector platform. So it's largely the connector that has to be different, the complete software and firmware that has to be different. And of course, power levels will be different because certain models of vehicles will have higher or larger battery packs. And to charge them faster, you need to increase the power level. So we do a complete platform. So essentially how we build products is it's from a range of even 350 watts to 3,300 watts, right? So this is a wide range of products that exists, but we've built platforms where the hardware essentially stays the same and you're just tweaking it out, but the software layer and the hardware interfaces and some of the features are what same. So I'd say that's where the main differentiator is. And that's also why companies like us, like IPEC, can serve multiple different OEMs simultaneously, because we're not re-engineering everything from scratch. We are actually having a common platform which is being tweaked and maybe customized in certain ways, and then we're building the final product.
For the end consumer who wants to buy an EV, but isn't sure of things like range, things like how close is the next charger, or if I go to a charging station, will I be able to charge my particular vehicle? What do those bottlenecks look like for the end consumer?
So right now, if you look at the kind of bottlenecks that are there for end consumers, it's that. So actually, there are two types of chargers. Let me put it this way, right? So one is a personal charger that you get when you buy a vehicle. Now, this is a charger which is already tightly integrated with the OEM software, with the hardware interface. And this is something that you will use to charge your vehicle at home. So that is pretty straightforward. The power levels are also defined, hence the charging times are also defined. And then there are absolutely no bottlenecks when it comes to that. Typically, you can charge your vehicle overnight, in 3 to 4 hours. And this is something that the users are also very familiar with because it's very similar to charging your phone at home, right? So it's very familiar to people. Where the actual bottlenecks are coming up these days, and if you ask me, that's on the public infrastructure side. So on the public infrastructure side, there are quite a few bottlenecks because there are actual different, I would say, layers that need to be tightly integrated for any user to have a seamless charging experience. So if you look at the first one is the actual physical connector. Now, let's say I have an Ether vehicle and I go to any public infrastructure. The first thing I need to see is does this connector, is it even compatible? Is the connector on my vehicle compatible with a connector on the charging station, right? So this is one sort of distinct layer which could cause friction. So this is a actual physical layer. The second thing is a protocol or software layer. Now, even if, let's say, the connector matches, but usually you need to also have software interoperability. And when I say software protocol, I mean this is also what the charger uses to talk to the BMS on the charger, right? So this also needs to be integrated. The third, I would say, is the power grid, like the grid conditions and quality, right? And this is like a very underappreciated kind of topic, which is because a charger that works, let's say, very well in other areas like Germany or China might not work well here, because those chargers have to work not only with the kind of voltage spikes, with the kind of unique Indian harmonic issues that are there. They have to be reliable. They need to not only look at phase imbalances, they have to look at even working in harsh Indian conditions like the dust, rain, heat. So these are some of the challenges that any user might face where, if they go to a particular place, the charger itself might not be working because of all these reasons, right? So currently, these are the three bottlenecks the way we see it. One is the actual hardware interface. Second is the actual software communication interface. And then third is, of course, the reliabilities of the charger themselves.
Like with mobile phones, for a long time, the debate was between type A, type B, type C, right? And obviously Europe eventually came to like a conclusion that, oh, type C is going to be the definitive standard. And of course, other countries followed suit, right? How do charging networks communicate with each other? What are sort of the what is the type C sort of equivalent of communicate? Of course, with mobile phones, it's a lot easier because you have Android, which is, I mean, you have different versions of Android, but you have they're still Android, right? They still have a similar core. What do those protocols look like when it comes to charging stations?
Yeah, so again, here there are two different types of charging protocols. So first, like I said, is the actual hardware interface. So if you look at India, initially there was a lot of fragmentation when it came to what kind of connectors people were using. And that is natural, right? Because when an industry is still new, OEMs and also are still trying to figure out what is the right approach to follow. So initially it was very fragmented, and now slowly you can see standardization happening. I'll just give you an example. So on the four-wheeler side, there is a standard called CCS2. Which is the combined charging standard. Now, this has become mandated for India, and all four-wheelers are coming on this CCS2 standard. Now, two-wheelers and three-wheelers, this is where, again, there's still, I would say in terms of standardization, has sort of, been slightly slower compared to four-wheelers. It's mainly because it is, countries like India that are leading the two-wheeler, three-wheeler EV revolution. And so a lot of people are looking at us to sort of define the way forward in terms of what the connectors will be, what the protocols will be. And that's exactly why initiatives like the LECCS, and there's also a consortium which IPEC has recently launched as a founding member along with Ather Energy and Hero Vida. It's called the Light Electric Vehicle Acceleration Forum. So it's called LEAF. And we are an active member there. And the main objective is to bring in standardization for two-wheeler, three-wheeler hardware and also software protocols. And this is an initiative that has just started. We launched this just last month. And we're in the process of bringing on other ecosystem players, because we know for standardization, it cannot be done in isolation. You need EV OEMs, you need charger OEMs, you also need network operators, infrastructure players. So we're trying to bring everybody together. So this is on the hardware side. So similarly on the software side, there's something called OCPP, which is the Open Charge Point Protocol. And this is, again, a standard communication protocol which exists between a charger and a back-end cloud-based management software, which we call as a CMS. So think of it like as a language that allows any charger to talk to any CMS, regardless of the manufacturer. So it's basically, so even if let's say the charger is manufactured by X, the CMS has been developed by Y, so charger X can seamlessly, let's say, integrate with the CMS. So similarly, another manufacturer, also ABC, can seamlessly integrate with the same CMS, right? So this is OCPP. Now OCPP has 1.6 version, which is what is now being used most predominantly. But OCPP has also now recently, I think, launched OCPP 2.1. This adds additional support for bidirectional charging, also vehicle to grid, smart charging also has been included in this. So this is for any charger to talk to any CMS. We also have protocols now for different CMSs also to talk to each other now. So it's not only about vehicle to charger, charger to cloud. It's also between different networks should also be able to talk, right? And so for that, you have something called OCPI, which is the Open Charge Point Interface. So this is for network to network roaming. So essentially, this is what currently exists as an overall I would say, architecture between vehicles, between chargers, between a backend cloud versus, let's say, multiple different clouds. So, yeah, it requires a much larger ecosystem play.
So if I'm not wrong, so currently there's this standardization of ports in with respect to four-wheelers, right? So you mean to say the four-wheelers use the same software? The software will be same throughout the four-wheelers, right? In that sense?
The communication software, yes. The communication language and the messages will be the same. So there'll be like a sequence of messages. For example, there will be an authentication process. And they have to talk the same language to the charger so the charger can understand it and then reply in a appropriate way. Otherwise charging won't happen.
Right. So that's gonna happen maybe in a couple of years with two-wheelers also. That's what you mean to say, with respect to all the leaf coming into place, right?
Yeah. So with Leaf coming into play, that's exactly what we're trying to do. We're trying to make this happen faster. If you see already Aether and Vida, they have a network which is interoperable. So other OEMs are also coming on board. And these are conversations that are already happening because, see, everybody realizes that there is also a regulatory pressure coming, right? So government policies are pushing this. BIS standards, which is the main standardization body for India, also has now recognized, LECCS, which is the Type 7 connector. At the same time, a lot of OEMs now are seeing the benefits of having a standardized network. They don't want to be left behind. And whoever joins this first or standardizes this first, these are the people who will shape how the standards are written for the future. And every OEM now knows that which side of the table they want to be on. And this is what we are leading the effort along with Aether and Vida. And honestly, it has been quite encouraging. We thought we'd face a lot of resistance, but OEMs have been quite welcoming. And I think not just OEMs, but different ecosystem players like charge point operators, infrastructure players, charging connector companies, charger companies are all coming together. So it's actually great to see from as an overall ecosystem.
When all of this is getting standardized, right? So there'll be a lot of already manufactured products at your factory or maybe at the user end or maybe at the company level. Also, you also might have products that are manufactured. So how are you planning to go about it? Because you are also a part of, standardizing the product, right? So are you carefully manufacturing products, order basis, or are you pre-manufacturing things for your OEMs?
No, so a lot of this is done in collaboration with the OEMs, right? And we know the direction in which the market is going, or where the technology is going, or where even the standards are going. So we already know that, and we're already part of larger, I would say, policy discussions, standardization, technical discussions. So we have a fair idea of where it is going. So everything that we're doing, whether we're designing the charger or designing the connector or even manufacturing these, we're keeping that sort of long-term window in mind. At the same time, everything that we do, we will make sure it's also backward compatible. So even for OEMs, if they're going to upgrade to something, they don't want their older or their initial users to get into issues, right? So everything will be backward compatible. On hardware, we might have to look at having adapters, like how even normally for any of your electronic appliances, you might have an adapter or a connector where the physical hardware interfaces don't match. These adapters will be also there on the software side, it could be on the hardware side. So these are the things that will have to come up. But I think what is clear is that the industry is still evolving. It's still evolving, and there's a lot of changes that are happening, but everyone is conscious that the early users, the early adopters will also have access to these changes, will not be left stranded in any way.
AI is taking over every product out there, every market. I want to know if you are integrating AI into your product as well. Like, also I want to know if the technology over time, it reduces the size of the product, right? Like, for example, back in the time, the mobile was really a big product and then became heavy to hold. Now it's really lightweight mobile phones. I know, I want to know if the chargers are also, getting upgraded, smaller in size, easy to take places, because currently the two-wheeler chargers are a little bulky to carry with you so that you can take to places and maybe charge it there as well.
Yeah, like there's a parallel. I think lithium-ion batteries would be a fair analogy to use, right? I think, we recently did a story on BYD where we sort of try to get into sort of how the blade battery sort of works and why, and the fact that they changed something in the packaging. So we're wondering whether you see a similar thing happening 5 years down the line, 10 years down the line.
Yeah, so I think that's already happening, at least when it comes to charging. That innovation, that miniaturization is already happening as we speak. So there are, of course, technologies that are being used. There are wide bandgap semiconductors, for example, silicon carbide, gallium nitride devices, and using these devices and building, let's say, chargers out of it will definitely help in terms of reducing the size and the footprint of chargers for the same power level. It will also improve efficiencies, right? So these technologies already exist. We are also working on them. So this is one sort of innovation that's happening in the industry where, let's say, chargers will be getting more compact, more efficient. And the other thing that's happening is, of course, power levels are increasing because battery packs, range, everything is increasing, right? People want more range and they want faster charging. So this won't be possible unless you increase the power level also. So we're also looking at higher power density, architectures to see how we can pack more power in the same form factor. So these are the kind of differentiated products that we're also working on. We're looking at even bidirectional charging. To give you an idea, it's a simple use case where, let's say, I have a charger which I'm currently using to charge my battery, right? But the battery is an energy storage device. So I should also have the option to, when I'm, let's say, it's fully charged or when I'm not really using the vehicle, and if I want to power a small load, if I'm outside or whether it's at home, and we should be able to also use the energy storage or the battery pack and then power, let's say, a few devices. So these are the different kind of products that are being developed already. And I think these are things that are rapidly evolving. So definitely there is innovation in terms of AI, because you mentioned AI earlier also. There is a lot of work in terms of the actual, on the cloud-based management software that I mentioned. There we are looking at building different algorithms to see how we can map out the kind of chargers that are connected to a particular grid, try to enable, let's say, dynamic load management to make sure that the grids at that point are not stressed at any stage. So there's a lot of work happening both on the hardware innovation side, software innovation side, and all of this is, getting integrated, also getting rolled out into the market in phases.
So we had a couple of questions on grid as well. Now, so you come from a legacy business of, selling power electronics, basically through Meher, right? Meher Group. So I want to know, what does Indian discoms actually look like to you? Considering the crucial role that you're playing, right? With respect to EV charging, what does, Indian discoms look like currently?
I'll slightly reframe the question a little bit. Like with Meher Group, you've probably dealt with the Indian grid, Indian discoms, sold to them as well, right? What was the relationship back then like? What is the relationship with, say, the Indian grid, Indian discoms, like when you're now expanding into the EV business?
So I think first, the Indian grid itself, I think, is a great engineering achievement. When you look at how it's catering to almost 1 billion plus people, there's extreme geographical diversity. There's also massive load variations, right? And it changes depending on the seasons. It changes depending on time of day. There's a lot of investment also that has happened in terms of not just power generation, but also transmission and then the last mile. And I think that over a period of time, at a power generation and transmission level, India has made significant progress. If you look at it, we're actually a power surplus country officially. The amount of power we generate is enough to meet our needs right now. But I think what India has is a distribution problem. right? And that's where the discoms and a lot of these players do come into the picture. But this distribution layer, which is mainly the 11 kV and the 415 volt lines, right? That's what actually connects the grid to, let's say, your neighborhood. Right now, a lot of these lines are overloaded. For example, transformers, which are serving these residential areas, were probably installed for requirements for maybe 10 years ago or a long time ago, right? So they are overloaded, they need to be upgraded. Even, for example, in the air conditioning loads that are coming into effect right now will be causing a strain on the grid, let alone, let's say, EV charging coming into the picture, right? And this is where the actual challenge is. It's to upgrade that distribution layer. And I think the generation transmission layer is fine in terms of the power grid. It's more on the distribution side. The other thing that's changing now is that grids are being forced to become bidirectional, also intelligent systems. For example, you'll have to integrate solar, so there's also rooftop solar. This is also being fed back into the grid. At the same time, energy storage systems are getting integrated, both at like utility level, also at like homes. Then you have EVs being charged. And these load profiles are completely different. You can't really predict when people are going to charge. So it's like a very dynamic load situation. So this entire monitoring of this requirement requires a lot of upgrade, a lot of engineering work, even let's say on the discom side. Because earlier discoms managed only like simple one-way flow. They were like static loads. But now they have to operate, it's a very complex real-time energy marketplace, and that's what it's slowly moving towards. And then we do have a lot of standards and protocols that are coming up now that are being written to enable this, but there's still a long way to go.
Yeah. So yeah, as we were talking about, how the power grid is actually built, the use case of 10 years ago, considering all the equipments, electronics being used currently, even including the EVs, right? If my iteration is correct, explanation is correct, I think the single phase and the three phase is what actually would make the difference, right? Like the single phase would have less electricity, whereas the three phase would provide more electricity. That's a simple definition of single phase and three phase, right? So considering all of the load increase, do you think there is a need for maybe upgrade of the single phase connection in the residential areas into three phase? Also, like who would bear the cost of maybe, in case if, for example, my building wants to have like maybe 2-3 EV cars in the place.
Sure. So I'll first start off with the single phase, three phase, that question that you asked, right? So we'll take it step by step. So if you look at a typical home right now, you'll have single phase, like residential connections in India. So these are typically limited to 5 kilowatt of sanctioned load. Sometimes you can go up to much higher, for, let's say, single phase of 7.5 kilowatt, but that depends on the discom and the tariff category. So now, normally, if I look at from a charging perspective, then the ideal sort of sweet spot for charging at home is around a 3.3 kilowatt charger. If you're looking at even on a two-wheeler, three-wheeler, four-wheeler, and if, let's say, the sanction load is available, you can even go up to a 7.4 kilowatt charger on single phase. So this is possible from a single phase infrastructure as well, right? And that's why most of our home charging systems fall within, let's say, our sub 3.3 kilowatt, and for four-wheelers will be typically either 3.3 or 7.4 kilowatt, because this is what majority of the Indian homes can support today, right? And but for example, if a household or a house needs more power, because let's say you have a family that has multiple EVs, wants to do overnight charging, then you have to apply for a three-phase connection. That's something that has to be done through a discom. You will need to apply for an upgrade, a connection upgrade. And this is something that then the discom will come, they will assess the feeder, they will say, okay, do you have capacity headroom? And then this cost, so there's a cost also that comes, right, associated with this. So depending on which state you are and which discom you fall under, it can vary. This can go from anywhere. Of course, this varies, but anywhere between, let's say, even 10,000 rupees to 30,000 rupees just for the connection. The timeline is also variable. And at the same time, this actually becomes the barrier for most people who live in homes. But what I'm trying to say is that if you, let's say, still stick to the single phase 3.3 kilowatt to 7.4 kilowatt, which is where the industry is currently at. I think, and if you do overnight charging, at least from a home perspective, because typically in a home use case, you do have time, right? So I don't need to increase power levels that much because the vehicle is going to be stationary for 5 to 6 hours at least, right? So there I can go with slow charging, continue to be at a single phase connection, also charge the vehicle fully overnight, and still be able to manage the, let's say, any use cases that you have in terms of charging. Any top-ups can be done on a public infrastructure. Now, public infrastructure doesn't have all of these constraints. Of course, they're also, if you're talking about a CPO or even an infrastructure player, they will anyway be setting up, fast charging, much higher capacity chargers. So this can be 60 kilowatt, 120 kilowatt, much faster charging station. So any top-ups that are required can, of course, be done on a public infrastructure. The day-to-day requirements can easily be taken care of by a single-phase connection at home.
Yeah, I actually had a question on transformers. So a few months ago on the Daily Brief, we sort of did a story on transformers, in particular, at least a shortage in high voltage power transformers. How much of a bottleneck do you think, because transformers are obviously installed like over long periods of time, right? Very likely that the apartment building that maybe you or I live in was installed probably 20 years ago. It's prone to blowouts when there are heavy loads. How much of a bottleneck do you think the state of transformers in Indian residences are?
I think because of the kind of load profiles that we are going to be seeing in the future, specifically because of EV charging now, becoming predominant, it is very important for the distribution transformers to be upgraded. This is a very, very important topic, right? And so if I look at, let's say, even a typical residential distribution transformer, which is serving 20 flats, let's say, or 20 or 30 flats in Bangalore. So typically these transformers will be rated anywhere between 100 kVA to 250 kVA, right? And all this load, usually if it comes to charging, will happen maybe in the evening. Right, so during the day you'll not have any issue. Everything will be perfectly fine. Your transformer will not be overloaded. Things will be working smoothly. But then now everybody comes back in the evening and everybody puts their ACs, chargers, everything, right, happens at the same time. So like the peak happens all at once. So that's the problem. It's this sort of imbalanced load profile that exists. What normally happens is that in the evening when this happens, right, usually the system will get overloaded. And when that happens, and when the transformer is working in this overload territory, that's when the thermal issues will start. So the transformer will run hotter, the insulation will age faster, then it'll fail prematurely. And that's why you'll have, let's say, transformers failing. Right? And then you'll also see things that where the voltages, which is at the further end of the feeder, will suddenly drop. And that will impact every device which is on the circuit. So now it's not only on the transformer, it's also other devices connected onto the circuit. So all of this, so that's why it's a very important topic that I think transformers have to be upgraded. At the same time, dynamic load management, that's what I was saying from a software level, where you have a CMS, a cloud-based management system, onto which multiple chargers are connected, and this system knows what the available load is or the capacity is, and based on that dynamically decides how much, let's say, power to distribute. And this is something that has to be done if we don't want to be stressing our power grids.
Understood. One question that I had on, like, because you're effectively selling equipment that needs to be plugged into a local discom, you will need to liaison with the local discom for this, right? Every state has discoms, and like from where we stand, we see a lot of variation, at least in terms of financial and operational performance in Indian discoms across the country, right? Like just moving out of Bangalore, do you think that this variation, how much of a variation is of this variation provides is a bottleneck for EV adoption in India, and how much of it is a policy problem?
That's a great question. So one, from an IPEC perspective, what I would say is that for us, we're in a reasonable sweet spot because we are supplying these through OEMs. So the OEM business is our largest business. So what we do is we sell our home chargers to OEMs. OEMs sell these chargers along with the vehicle, and people use these chargers at home to charge their vehicle, right? So there I'm essentially never interfacing with a discom, other than the fact, of course, that our products have to be actually designed to weather these kind of conditions, the electrical grid conditions. Other than that, we have no interaction with discoms directly. On the public infrastructure side, there also we're working with very good partners. For example, Lawrence Knudsen is one of our partners. They are essentially going to be taking care of the marketing and the actual installation, commissioning, and they will be doing those interactions with discoms. Right? So from an IPEC perspective, I'd say for us it's a limited problem, but it's a very important problem in terms of the industry. So that I'll take like a more sort of like independent view of how things would work there. And but you are right that this variation of like different discoms is something is an important factor. And I mean, mainly I think one of the things, of course, is things like the technical and commercial losses that exist, the kind of financial health, the voltage regulation, quality of the power grid, then also the quality of the technical staff that exists there. It varies a lot. There are some discoms which are very well run, like Bescom in Karnataka, for example. I'm not just saying this because I'm from Karnataka, but for example, there are other discoms, right, which aren't as well run, and there you do have to have products that work well in those kind of environments, like power grid conditions. So there, what we do is we try, as our approach is to engineer for like worst case grid conditions always, right? And what this means is our product will have like a wider input voltage tolerance. We have a much higher surge protection level. Just to give you an example, we build for 6 kV surge, which is like unheard of everywhere. People maybe do like 4 kV surge. Here we're building systems for like 6 kV surge. We also have to take care of a lot of like these voltage fluctuations that come in primarily on the input side. So this makes our products more robust, more reliable for sure, and that's how we're ensuring that they don't fail in the field, irrespective of where the user plugs in this charger. So that way, from a product level, we're making it robust, so that the power grid condition shouldn't matter. But when it comes to, let's say, on a EV, like on a policy side, the central government so far has had BME drive schemes. There are multiple state level EV policies that have already been rolled out or in the process of being rolled out. Recently, there was even the Delhi EV policy. So there you're seeing that in addition to giving subsidies for consumers and purchase or let's say demand side subsidies, the allocation of let's say support to upgrading discoms and for EV infrastructure is still like relatively low. But that is slowly changing now because I think even the government and everybody has also realized that discoms need to upgrade their infrastructure and be EV ready. That means ready for supplying EV loads, which are very dynamic. And so they have to take this seriously. It's also a great opportunity for discoms because this will be like an additional revenue for them, which they can see, right? So if you also look at the kind of financial health of theirs, they can actually see this as an opportunity to upgrade themselves. And this is something that from a policy level is happening. Investments are slowly rolling in, but yeah, transformers need to be upgraded, cables have to be upgraded, even the metering side, in anticipation for the kind of EV load that is going to increase. This has to be done, and this is something that is still at initial stages, but there is a lot of thought going into this, and I think now with the awareness coming in, a lot of effort is being put in, and this will eventually happen.
So with respect to our discoms, right? Previous videos where you were like specifically telling their like irregularities or rate spikes. But I want to know what are these kind of fluctuations or spikes that these German or for example Chinese chargers are not ready for, because as you told previously that these chargers cannot withstand India's conditions. Do you have anything in place to maybe consider someone buying a EV that has a Chinese charger? Do you have something in place to replace those chargers which actually support those ports or maybe those software the EV product comes with?
So in terms of the grid conditions, I would say that of course India does still have power quality issues. We currently operate on a 415 volt 3-phase system, which is 50 hertz. So for single phase, that typically means it's a 240 volts AC system. That's the single phase sort of voltage that you're getting from a regular socket. But you'll see that in reality, you can see voltages like going less than 200 volts also. It'll go up to 300 volts also, even though the nominal voltages should be 240 volts, right? So this could be because of like during peak demand, you will see a sudden voltage sag. You could also have issues where voltage fluctuations where suddenly there's a spike, like surges can also happen. So that way the product should have a wide input voltage range. It should be able to withstand a wide input voltage range, even though nominal voltage might be 240, but it should be able to withstand as low as let's say 160 volts, even going up to let's say 300 320 volts, right? So one is this wide input voltage range, which a lot of the products which are designed for Europe and China do not have, because they have more stable grids. If those products come here, they will easily fail, right? Just because of the input side and not being able to withstand that wide input voltage. The second thing is even on surge, like I mentioned earlier, our devices or products need to be able to withstand a 6 kV surge. But typically in other, let's say Germany, like a 4 kV surge is something that's more than enough, right? You never see anything beyond that because it's a more stable grid. And then, of course, those are just on the electrical side. But then also, if you look at the kind of temperatures we have, the kind of dust, the kind of vibrations we have because of the road conditions, because these chargers will either be portable chargers that are kept in the boot of your vehicle, or they're onboard chargers which are mounted into the vehicle, or they also see a lot of vibration, water ingress because of the kind of rains that we have. So it should be able to withstand water ingress, dust ingress, vibration, humidity. And this is all in addition to the power grid conditions and issues that I mentioned, right? So I would say a product that is developed for India can withstand can work anywhere in the most reliable way. We're like stress testing massively stress tested. So, but that's the reality, and I think, and that's also an advantage, like a competitive advantage. Is I think that we would have, because one, we're forced to build like very reliable products, but India is also a very large market, right? So you're also not only building these products, you're building them at scale. So it'll be reliable, but you can also make them cost competitive, and then you can export these to any part of the world because they will work anywhere. So I actually see that as an advantage. So whether it's like a Chinese charger or a German-made charger, I would say we'll do it better and cheaper, and so that's like a competitive edge we have because of our circumstances.
So earlier this year, India had released a draft electricity policy, which is sort of like the whole thing about hey, we need to modernize our grid, we need to change how even power procurement contracts work and everything. But the biggest, I think, change was where they looked at renewables in the grid, like in the entire scheme of the Indian grid, right? How important, like, do you think the Indian electricity, like the electricity policy side of things talks to, say, the e-drive scheme side of things, right? How, what does communication look like between those two things? And secondly, how important do you think BESS then becomes, right? Because we know the Indian government's trying to push a lot of BESS tenders. EVs get charged a lot in the evening. You would need that kind of BESS to store energy that you get only in the morning and afternoon.
Yeah, so that's what I'm saying. The entire, I'd say, energy infrastructure needs to be relooked at, right? So the government has the right idea in that sense, where they're saying, okay, this needs to be upgraded, this needs to be, rethought of. And so those policies and those sort of efforts are going in the right direction because renewables are getting integrated into the grid. Again, that is why you need energy storage, right? Because it's usually renewables are intermittent. So whether it's solar or wind, it's intermittent. So if you want it to be a stable sort of source of energy, you have to store it and then supply it when it's being utilized, because when it's being generated is not necessarily the same time that is being utilized. So like if you just look at solar, you will have more generation happening in the morning, but then the actual consumption might be happening, like the peak might be happening in the evening, right, when there's no sun. So that's why integrating energy storage also is so important. And at the same time, power electronics is extremely important, which is at the core of each of these things. Because without power electronics, you can't, let's say, generate power from solar, because that DC has to then be stored into a battery that again needs to be inverted into AC and fed back into a grid. So all of this requires a lot of coordination, a lot of integration, a lot of standards, protocols, and also taking care of safety in mind, right? So safety is also a very important aspect. These are not being done at like very low power levels also. So that's why all of this needs to be integrated, and that's why it's so important to have a very clear policy, standardization, safety framework, which will allow all of this to happen or enable all of this to happen.
So there might be a lot of components or parts you might be importing, right? So what do you think is that one component that's really hard to locally manufacture?
We've seen you talk about the need for self-reliance in a lot of your past interviews, particularly on Chinese supply chains, right? So what's the hardest component that you think hard from a localization standpoint?
If we look at any power electronic device, whether it's a charger or an inverter or a DC-DC converter, so essentially it has this, it's a converter, which is a PCBA. And in this, you have electronic components. So these electronic components are typically semiconductors. So these could be either MOSFETs or IGBTs. These are the core switching elements in any power electronic device. Will have these MOSFETs or IGBTs, basically semiconductors, right? So power semiconductors. Now you have not only these power semiconductors, all of these need to be controlled by a particular algorithm, which is why you need a microcontroller. Now this microcontroller also is essentially both these, the semiconductors and these microcontrollers are currently being imported. India does not have a mature semiconductor ecosystem. The government, of course, is trying to change this with the different PLI, which are the production-linked incentive schemes that have come up. And so now you see a lot of companies investing in semiconductor fabrication in India. But that'll still take time to mature, right? That's still going to take maybe 3 to 5 years to mature, to reach the kind of industrialization and the kind of price points that exist in the industry today when I, let's say, import from China or Taiwan. So the hardest part, if you ask me, would be the semiconductors and microcontrollers to indigenize or localize. Because you see right now, almost all of these are being primarily imported either from, China. These are mainly the, US, European, Japanese manufacturers. All their supply chains are in either China or Taiwan. And so that's just the reality of the supply chain and how it exists. But like I said, government is pushing this. A lot of policies, incentives are in place. We are going to see that changing, let's say, in the next 3 to 5 years, but not anytime soon. And the other thing is that the other components, for example, the bare PCBs, there are also magnetics, which are like transformers and inductors. These are slightly easier to localize because also the kind of capex that they require, the kind of investment that they require are relatively lower compared to, let's say, setting up semiconductor fab. So these, I would say, are the next in line in terms of difficulty level. And post that, all other things, like, for example, there are passive components like capacitors, inductors, that now India, of course, has some very great capacitor manufacturers also who have locally designed and developed these products. One of our investors, also DK Electronics, have localized these components, these capacitors. We're actually in the process of trying to localize those here and buy them from India rather than importing them. So passives, I would say, are next, which are mainly capacitors, resistors. And then, of course, all the other things, which are right from enclosures, aluminum die castings, cables, plastic, rubber parts, all of those mechanicals, that already a very good ecosystem and supply chain exists in India, and those have already been localized. So right now, if you look at our current DVA, which is what is called domestic value add, like that's the term that's like normally used in industry, our DVA or domestic value add is already more than 55%, which means 55% of whatever we build is already localized in India. The remaining is because of these bottlenecks, like I mentioned, which is mainly the semiconductors, microcontrollers, then the bare PCB and magnetics. These are the main bottlenecks, which I would, like I said, would take probably 3 to 5 years still.
So, for example, when one of the OEMs who's your customer, right? So they might upgrade their battery chemistry or change their BMS. It'll cost you a hefty amount of money as well for the R&D of designing a new charger. Now, the entire process, who takes a hit? Like, as in, who pays for it? As in, you take a hit because they are your customers, and later in the day, anyways, you'll have to manufacture a lot of products for them.
So typically it's done on a case-to-case basis. It really depends on the kind of change or upgrade that they're asking for. So typically, if it's only a battery chemistry change, usually that means on the charger side only, like, 3 things can happen. Either they want a different power level. Second is, of course, the charging protocol, which the firmware would have to be, or the software would have to be upgraded to match the revised charging profile for that particular chemistry. And the third is if there are any actual physical, mechanical interfaces that need to be changed, right? So like, these are the 3 main categories that we would see. Either the whole power level will change, or your software and integration work would have to be redone, and then your actual physical or mechanical interfaces. Now, if it is like a small change, usually that's something that we will only take care of. And any NRE charges, which are like the industry term, which is like a non-recurring engineering charges, what we do is normally we invest as a company, because we know that these are OEM relationships that we have. The kind of business volume that they will give us in the future is very large. So these are also multi-hundred crores of like projects, right? So we take that call and decide to invest. And this is how it's been happening. So whether it's on the power level, upgrading a charger, or whether it's redoing the complete software to integrate with the new battery chemistry, or whatever that is, usually that is something that we invest. But normally, if there's something very customized, very specific, which we cannot use for any other OEM, in that case, of course, there is a discussion that happens. We do give those proposals where the OEMs do agree to invest partially, sometimes partially or even fully. But yeah, so it's on a case-to-case basis, and it also depends on the kind of change, how customized it is that they are asking for. Some of them would want to, let's say, own the tooling for some of these outer enclosures because on aesthetic side, they want to control what the outer layer of the product looks like. And that is, again, customized only to them. We can't use that for anybody else. So they know that. So the minute it's an aesthetic part which they don't want us to use for anybody else, and if it requires expensive tooling, it's clear that the OEM will pay for it. So there's no sort of one fixed rule. It depends on a case-to-case basis.
So I think the design of these chargers, I think they're patented, right? Like for each of the companies, if I'm not wrong. I don't know if they're patented or not, but the socket, the connectors, all of this is different right now for two-wheelers. Now, if they're patented, then it makes sense that these OEMs actually have to design it differently. Now, consider two OEMs coming to you and giving you a design, and you know that that particular design is already owned by somebody else. Do you say no to that particular design, or you help them redesign, redesign the socket or the connector in a different way, help them out in their business?
Just as a follow-up to that, in this scenario, what part of the process is your own intellectual property, like IPEC's intellectual property?
Okay, so see, that's the main, like I said, the hardware, power electronics part, the software, the firmware and the software that resides on top of it. And then, of course, any of the manufacturing processes that we deploy to manufacture this product, right? So this is something that is proprietary to us. So typically OEMs come to us with specifications. And when they come to us with specifications, it's up to us on how we want to configure the product internally and then supply it to them. That's what I was trying to tell you earlier, that even though if two OEMs have the same power rating, we might use the similar hardware inside, just change the software layer on top of it and just the connector interface. And inside it's essentially the same product, right? So there it's only a spec that is given. So there is absolutely no concern if I use, let's say, the rectifier module in both products. There's absolutely no issue. We also work in contract manufacturing mode, where some OEMs might come to us and say that, hey, we want this very specific charger, we've designed it, but we want you to just manufacture it. So that's a different mode. So what I explained earlier was the ODM, which is the original design mode. Contract manufacturing mode is a separate mode where an OEM gives you the complete design, like not only a specification, they give you a complete design, the complete blueprints, drawings, everything. And there's a separate agreement where you're clear that you cannot manufacture this product for anybody else. So the terms are very clear. And that there's no conflict or anything that appears, because you're working in different modes. So that's usually how it works.
So do you see any risk of these OEMs entering into your business? So basically, they're developing their own charger. Maybe tomorrow, one of your OEM comes and tells, we have enough technology in-house to build our own chargers. So do you see that as a risk for yourself?
I think that's a risk always for any industry where you can have backward integration, right? And OEMs, of course, do have very large access to capital, budgets, teams, so they can easily do this if they want to. But I think what is important that us as a charging partner to these OEMs have to add value to them. And if they see the value that we add, they will want to continue to work with us. So whether that value is being offered by launching innovative products faster than what they are able to do, that is one value that you can add, right? Okay, they're working on a certain charger, but we are working on miniaturizing it. We are working on increasing the power density in the same form factor. because we are more focused on charging. They are looking at the entire vehicle, and so our focus is more on this product, so we can innovate faster than them, right? So that's one value. And if they had to build a team to do the same thing, they would require much larger teams, a lot of effort that goes into it, resources that go into it, which also comes at a cost. So one, they'll see we are experts in this, we understand this very well, we are innovating faster. The second thing is that because as a supplier or a partner to them, we'll have economies of scale, because we're supplying these not only to them, we're also supplying this to like 10 other EV manufacturers. So it's not just the volume of this. So it's not, let's say it's not just Ather's volume or Bajaj's volume. We're supplying to, let's say, everyone. So I'm able, because I am buying a lot more components, because I'm manufacturing a lot more components, I am able to do it much more in a more efficient way, in a more cost-effective way. And I basically have economies of scale. So if you're giving the technology innovation advantage, if you're giving the economies of scale competitive advantage, you're also de-risking a lot of their supply chain issues, which is a big thing these days. So if you're able to add that value, I think OEMs definitely see that, and then they'll want to work to their strengths and their core, which is manufacturing vehicles rather than charging systems and power management systems. So that is the sort. At least that's how I think it'll go.
From what little we know, vertical integration has obviously been a big feature, not just in India, like not just with say Ather or TVS or Bajaj, but obviously even Chinese brands like say BYD or Geely, right? It probably partly because it's an early industry. It's like there is still a lot more yet to go, like a lot more progress left. Very similarly, back when Ford built its first car, right? They chose to vertically integrate because obviously in the market there were no like suppliers for the various components, right? How do you see this particular trend evolve, fragment from where you sit, right? From the business that you do?
So I think, of course, vertical integration is very important initially on, right? Because these are, like you rightly said, from a technology point of view, still very new. A lot of rapid technology advancements are happening. So OEMs, as much as possible, want to have control or access to the entire piece to be able to give that differentiator or that better user experience, right, by having more seamlessly integrated systems. So that is the thought process initially. But I think as adoption grows, as the industry and market also grows and matures, it's not only about integrating something, it's also about constantly upgrading something, it's also about scaling something up. And all of that cannot be done in isolation by one, let's say, entity. If you look at the automotive industry right now, the traditional IC engine vehicle industry, you will see that there's a very large ecosystem of OEMs, tier 1s, tier 2s, tier 3s that exist because of the kind of innovation, the kind of scale, volumes, after sales support, the kind of and here in this case, you also have, infrastructure, like power infrastructure also coming in. So all of this will require a much larger ecosystem play. It will require a lot of multidisciplinary capabilities. And I think people will also realize that they would want to focus their resources on where they should. And the other things can be worked in a more collaborative partnership mode if we really want to scale. Because India itself is a large market. More than 23 million vehicles are sold every year. We not only want to provide for India, we want to also export globally. So I think there's a lot of work that needs to be done, and which is why focus is required. And if we try to do everything all at once, then it's probably not the most efficient way to work.
Plus, obviously, India has one of the largest auto ancillary industries, at least in internal combustion.
Yeah.
So, which is why also we partly asked you this question, because we see that fragmentation.
No, No, and that'll happen eventually because, like I said, anywhere where there is scale, anywhere that there are multidisciplinary stakeholders coming in order to enable and scale an ecosystem, you do need collaboration. It's otherwise the kind of resources or the kind of effort that is required is very, very large. Like there is an OEM that tried to do this. I'm not going to name them. It's a two-wheeler OEM. You can see how it has impacted them. And now they're pivoting into becoming an energy storage company from a two-wheeler EV company. But I mean, it does impact because I think focus is very important.
So, as in, you have already answered that, but I just want to, ask you again. Pranav, absolutely loves this company, BYD, which is a Chinese company. But, you might have heard him say BYD at least twice in this call. But again, regarding BYD, they were battery manufacturers first, and then they, started manufacturing cars now. So, are we gonna see a IPEC scooter maybe in 5 or 10 years down the line?
Definitely not. That I can tell you for sure. Because, like I said, our ambition and vision is to be a power electronics company because we truly believe that energy transitions are happening around us, not only in power generation, like, let's say, renewables, but also in transportation from, let's say, IC engine vehicles going to EVs. And none of this will be possible without power electronics because power electronics sits at the core. So our focus is to be a power electronics company, to build products for the EV industry, to build products for, let's say, renewables, to build products for energy storage. So it's a very different ambition. And also we wouldn't want, like I was just talking about focus earlier, and so we'd want to continue that focus. And of course, I wouldn't want to go and compete with my customers, which I don't want to do ever. Yeah. So I think we're very clear in terms of where we want to play, what our advantages is. At Meher, our background was always power systems, power distribution, power quality, and that's what we know and that's what we're good at. And that's why we're going to continue in the power electronics space. And we will let the EV OEMs do the amazing work that they're doing, and we will continue to support them with any of the power electronic products that they need.
Awesome. Last question, which is, what's your outlook like for fiscal year 2027? What are you excited about?
So IPEC, for this year, a lot of great things are happening. One, purely in terms of business size, we are going to be doubling in terms of sales. So that is a challenge where we're in the process of expanding capacities very aggressively because the EV industry is growing very rapidly. And we've onboarded new customers as well. So one, sort of servicing this 2x growth that we're seeing, which requires, but basically the 5 M's, which is manpower, it's method, it's machinery, it's materials, and then of course money. So it requires all of these to be enhanced, to be upgraded, to just have a 2x output. This is something that we're pretty excited about. The team is also getting strengthened. At the same time, we're developing a lot of new products. The bidirectional charger is one product which I'm especially excited about because like I said, it's a different use case where I'm not only able to use the charger to charge the vehicle, but then I can also use this charger to then use the energy that's stored in the battery to power a small load. And that's a use case that can be used even in, let's say, not only tier 1 cities, but tier 2, tier 3 rural India also, where, let's say, they might have power outages, and then you can just use the remaining charge on your, let's say, vehicle to power a small load, like a lighting load or any other load that you might want to use. So we have those products coming out. We are also rolling out the complete end-to-end EV charging solutions, which is the hardware, CMS, mobile app. And we're doing this in collaboration with Lauritz Knudsen, which is a Schneider Electric company. So that will be a very new sort of segment for us. And so we're quite excited about that as well.
Great.
Awesome. Great. Thank you so much, Zohra, for doing this. This was a fascinating conversation where we got to learn a lot. And yeah, I think I'll be thinking about a lot of things on this conversation. Yeah, this was a really fascinating conversation. Thank you so much.
Thank you, Zohra.
Thank you so much, guys. Thank you so much for having me.